Welcome to Real Civil YouTube channel. In this video, I am going to discuss you about the what is plastic hinge. I have made several videos on the nonlinear static analysis, or I would say nonlinear analysis using ETABS software, SAP software. Then I have discussed about the concept of nonlinear static analysis. Okay. So before going for plastic hinge or what is plastic hinge, first I would like to clear why we go for nonlinear analysis. So there are several reasons. Okay, just for the understanding I would like to give only one example. For example, if you have one structure and that structure is subjected to very high ground motion or a huge earthquake. So at that time, your structure may get uh, a large displacement. Okay, so that means your structure may experience inelastic action. So at that time, performing the linear analysis will not be correct. So at that time, we do the nonlinear analysis. Okay, so that is the first thing why we perform the nonlinear analysis. Now, in nonlinear modeling, there are two approaches. The first approach is called as the distributed. It is the distributed plasticity approach. Distributed plasticity approach, and the second is called as concentrated or lumped plasticity approach. Okay, so I will give you very simple example that will clear what is the difference between distributed plasticity approach and what is concentrated lumped plasticity approach. So for example, if we have the beam and if we incorporate the non-linearity, I will explain do I what is the meaning of non-linearity actually. Uh, in distributed plasticity approach, the non-linearity is defined over the entire length. In our case, over entire length of the beam or some part of the beam. Okay, either you will assign for entire length or you will assign for some part of the beam length. Here we have considered beam, that's why I'm saying it is beam. So this is called as fiber modeling approach. This is called as fiber modeling approach. Okay, now what is concentrated or lumped plasticity approach? For example, if we consider the same beam and now we incorporate the non-linearity at a certain points only. Okay, at a certain points only, and in between these points our model is elastic. Only at these 2 points we have incorporated the non-linearity. Then this approach is called as plastic hinge approach. So this is called as plastic hinge approach. Okay, so here we assign for entire length or some part of the length, whereas in concentrated or lumped plasticity approach we assign or incorporate the non-linearity at a certain points only. Okay, now What do I mean with introducing the non-linearity? To explain that, I will take one beam. Again, I will go with the example of beam, and suppose in that beam, if we apply the moment, okay, if we apply the moment, what happens? This beam will bend. That means it has some rotation theta, right? We know that if we apply the moment, there will be rotation. If we apply the force, there will be displacement. Okay. So if your computer model is linear, then the action versus deformation, that is m versus theta, is linear. This graph is linear. Okay. So you can apply the high moments, and suppose if you apply the high moments, you will get the corresponding high theta. Okay. But in reality, your column may not be able to take those high movements or high rotation. Okay. So in that case, it may fail before development of those high movements. Okay. So in that case, linear elastic model will not give the correct answer. Okay. It may deceive. Okay. So that's why we need to go for nonlinear analysis. So what happens in nonlinear analysis? The action versus deformation curve, that is for example m versus theta. Here it could be force versus displacement also. So the curve is linear up to yield point, then so this is the situation. So the our input, if we are introducing the non-linearity, that means we are introducing that this behavior of movement versus rotation or the action versus deformation. Okay. It is not linear. So this way or this pattern, in that pattern, we our structure will be analyzed. Or for example, as I told you, in the lumped plasticity approach, we define the non-linearity at certain points. For example, these are the 2 points. Then that means this behavior is applicable to these 2 points. In between, it is linear. Okay. So what happens then? It give the correct prediction of the movement, rotation, or the if our structure is getting fail or not. So this is the real behavior. So that's why we incorporate this behavior in nonlinear modeling. So simply the definition would be, by assigning or by defining the plastic hinge, that means we tell the computer program that my these two points will be following this movement versus rotation curve, which is given by the user itself. Or plastic hinge means we incorporate the non-linearity at the member level. Okay, so member is non-linear, and the practical way to do this is this plastic hinge. I hope you get the difference between. So that is the difference in linear analysis. The moment versus rotation, force versus displacement, this is linear. But here, up to this point, it is linear. We call this point as yield point or moment at yield. This is maximum moment or moment capacity. Corresponding theta here It's called as maximum theta or theta capacity beyond which it will fail. Okay. Now, I hope the concept is clear. The graph of action versus deformation is different in uh, 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 nonlinear modeling. Now, the next question is how can we give this behavior? So, one way is to perform the experiment, get the data, and put it as an input. But it is not always possible to do the practical. Okay, do the experiment because we have heavy sections and it is not possible to yield those sections always. So we have another approach where we have one code ASCE 4117. In that, the modeling parameters are given. Okay, so to define this curve, here you can see this is up to yield point. Okay, then the modeling parameters are A, B, and C. Okay, if you define these A, B, and C, your curve will automatically gets generated. A to B, it is linear. It is always known what is the yield and all those things. Then what is from this yield point to the maximum capacity, movement capacity. So this is your A. You can get the corresponding theta also here. Okay. Then from this point to this point is B, and this is your C. If you define this A, B, C, then your curve is automatically gets generated. And for different concepts, for different sections, different situations, these ABCs are given in ASCE 4117. So you can refer this particular code. And then there are acceptance criteria. The limits of acceptance criteria are also defined in ASCE 4117. So these acceptance criteria are nothing but like you may define the immediate occupancy here, then life safety, collapse prevention. So the limit of these are also given in ASCE 4117. So this is your complete nonlinear modeling approach. Here one is because it is normalized with yield movement. Okay. So here you can see M upon M yield. Okay. So that's why it is 1 here. Okay, I hope the concept of nonlinear modeling, plastic hinge, and how to define this is clear. If you still have any doubt, you can ask me. Thank you so much. Please like, share, subscribe the channel. You can donate us through thanks tab also, which is given in the YouTube. Thank you. Thank you so much.